Hey guys, welcome to a new video on the Cell Doctor channel. On this video we're gonna look on this brand new old scooter. Actually, I got it from a local site, OLX. It was 100 bucks. It's a dead e-scooter. It actually came packed like this. I didn't look inside to see what's up. So let's start cutting and see what's inside. If there are some bricks, or I can see a wheel sticking out here. So hopefully will be something that we can work on. The idea will be to see what's wrong with this e-scooter. It should be a Ninebot E-Scooter, which I'm familiar with because I repaired a few of these. I'm curious to see if it's the battery or if it's the controller or anything else like the display or any shortings. So we'll make a mini series with this e-scooter, trying to debug and see what's wrong with it. The seller looked to be someone that's repairing electronics, because his photo said that he's repairing electronics. So he tried to find the issue. He disassembled it and did not spend the time to put it back, but at least it looks like we have all the parts right here. Ninebot by Segway. We have the controller here, the battery, hopefully it's in here somewhere as well. It might be in the tube or at the bottom. Let's see. Okay, let me remove this from here. It's good that it also has a charger with it. So I will not have to spend any money to get a new charger for this e-scooter. The plan is to fix it and to sell it, obviously, because I don't need two e-scooters. So this is the charger. We'll have to test to see if that works as well. But let's finish unpacking this. So this is how the display looks. It has all the connectors, which is good. No extra work to get those fixed. Whoa. And this is the battery. There's no LED turning on this one. Oh, it is. It's flashing red. Flashing red. That doesn't seem to be a good sign. And by the looks of it, someone tried to open it as well. And I will probably start with this first. Let's see if it's a dead battery or not. Here are the screws, which is okay. Still has all the screws in. I'm gonna leave this on the side here. And want to see if it locks. Ah, there's the cable. Yeah, it seems to be locking fine. There's some issue with the cable here. It has some isolating tape, which is not very good. It should at least have some thermal tube. The motor is spinning, so there's no sign of it being blocked or something. Right, so they definitely checked the controller. Maybe look to see if there's any issues with the MOSFETs, probably. That will be the next thing for me to check after I look into the battery. If the battery works fine, accept charging, and it's all good. I will look into the controller to see if it needs to be fixed. Let me put this down for now. From my experience, the order in which things are getting broken on this e-scooter is the first battery. The battery will stop working if it was not charged for a long time, and it will require some resuscitation. There are a few ways to charge this via the wires. You can try charging these on the balancing wires. I saw someone mentioning this, but I always like to look inside to see if all the cells are properly balanced. If I'm getting to this stage. And most of the times that was the issue. The cells were under 2.5 volts, and I had to balance them one by one. Balancing can be done in multiple ways. We have developed a tool that allows us to charge them all at once. The good part is that it looks like nobody looked into the battery, because the silicone looks to be intact, but we'll see in a second if I'm right or not. Okay, so it looks like an original battery. And I think there are still some screws. Yeah, they are inside here. There are some screws that must be taken off in order to remove this. Let me get my trusty small screwdriver and work my way with these screws. Yeah, definitely it was not opened before, because it still has the silicone, the original silicone of all these screws, so I'm happy with that, because the problem might be close to the domain I'm most used to. I changed some MOSFETs in the past successfully, but I'm not eager to do that. And where's the head? My head. Alright. Let me get you closer to show you what I'm doing here. Okay. So you see behind these small dots right here, there are some screws. And it's a good idea to put the silicone back after you finish with the repair, because I think they had a good reason to bother with this. And now I was able to take this off. So this BMS part, so this is the BMS part, which is easily removed after unscrewing everything. Okay, so that was the top BMS, and there's another bottom BMS right here, which actually has the big MOSFETs for stopping the charging and the discharging. I'm not going to disassemble it yet. I just want to measure the voltage on the cells. I'm going to get the multimeter, set it on voltage. Alright, set it on voltage, and let's check the cells. See how they are grouped. .8, and we have 35 volts. So the battery appears to have voltage. And let's check the individual cells now. This is negative, positive, 3.8, 3.8, 3.8, 3.8. And this one appears to be dead. So from here we have 3.8, and this cell, it's either disconnected or something happened with it, because it's dead. It's 0.07 volts. Let's check the rest of the pack. 3.9, 3.9, 3.9, 3.9, 3.9. So all the cells but this one are working fine, and that's like I said, usually it's a problem with the batteries, and it can be a problem with the BMSs also, because they are not using energy from all the packs, they use energy from one cell to keep them alive. I did not study this BMS too much, but I worked with others before and they had similar issue. So that's what most of the time happens with other packs as well. One of the cells will get disconnected or get discharged. I'm not sure which one is the case here, but I will attempt to charge this one to see if it receives any energy. To do this, I'm going to solder two wires to make it easier for me to push some energy in this. I will try to wake this up, and then I will do a capacity test on these two cells using our Megacell Charger. This way we'll know for sure if these cells are in a good shape or if they need to be replaced. If one of them is damaged, has a short in it, it will give a smaller capacity than it should, and I think these are 2.5 amp hours, so they are 2500 milliamps cells, and the capacity should be around 5000 milliamps if they are alright. So let me get two wires. I'll place a dot of solder here to attach my wire. Make sure you check the polarity. You don't want to try charging the cell in reverse polarity. When it's dead, it's quite easy to do such mistake. But with the 18650 cells, you will see a small indentation at the top, and that shows you that's the positive side. Alright, I attached two wires. I'm going to check the voltage again. So 0.08 is the voltage. I'm using range power supply. I will set this one on 3.5 volts. Like I mentioned before, I'm just trying to wake this up, not trying to fully charge it. I will limit the current so it will not rush the cell with 3 amps. What's the capability of this power supply? It's too much when trying to wake up a cell, so I will limit it, see if it receives any power, and it does. You see it limited at 0.05 amps, and now I will start raising the current to about 200 milliamps. Now it's charging slowly. Once it reaches 2 volts, I can hook this up on the Megacell Charger, and I will show you the process for testing this cell that's already assembled here. It charges slowly, so that's a good sign. That's not raising the voltage too quickly. The cells are recovering maybe, and once it reaches 2 volts, we'll place it on the Megacell Charger. When you do such recovery, make sure you check the temperature. If the cell is shorted, it will start heating up. These cells are not heating at all. The current is not that big, but But if the cell is shorted, it will transform that current into heat, and you'll feel it quite fast. I connected the cells to the Megacell Charger Pro, the commercial version. It detected it as a low voltage cell. I set the charging voltage to 4.24 and the store voltage to 3.8 volts. It's going to perform a capacity test and then store the cell. For now it charges with 131 milliamps because it's a low voltage cell. Until it reaches 2.8 volt, it will slowly charge it, and after that it will charge it with the set current, which in this case was 2 amps, and it will discharge it with 1 amp, and after that we'll see what kind of capacity we still have in this cell and if they need to be replaced or not. We'll see you in the next video where we check the results of this test and take it from there to see what it takes to repair this Ninebot E-Scooter. See you soon.